Okay, so this is going to be another video for Mrs. T's Chem Talk Regents Review, going over the blue exam. And for those of you not in my class or who don't remember, the blue exam is January of 2014. This video will go over questions 51 to 85. Okay, so looking at this reading, it says base your answers to questions 51 to 54 on the information below and on your knowledge of chemistry. Oops. Okay, so back to January of 2014, 51 to 54. Remember, anytime the reading says a specific set of questions, you always want to reread and look through the reading again each time you answer a question in that set to make sure you're not missing something. Base your answers questions 51 to 54 on the information below and on your knowledge of chemistry. And it says that the diagram below represents three elements in group 13. Aluminum, gallium, and indium are the ones in the same group. And in period 3, aluminum, silicon, and phosphorus are in period 3. So the ones in the same group have the same number of valence electrons. The ones in the same period have the same number of shells of electrons. Some elements in the solid phase exist in different forms that vary in their physical properties. For example, at room temperature, red phosphorus has a density of 2.16 grams per centimeter cubed, and white phosphorus has a density of 1.823 grams per centimeter cubed. In this part of the question, they are describing allotropes. Number 51, identify the element from the diagram that will react with chlorine to form a compound with the general formula XCl4. We need to find the oxidation number of X. Filling in the -1 for chlorine gives us a +4 for X. And in the diagram, silicon is the one that has a possibility of a +4 oxidation number. Remember, we find those on the periodic table. It says consider the period 3 elements in order of increasing atomic number. Period 3 elements, what they're talking about, would be aluminum, silicon, and phosphorus. We're going to look up the electronegativity values on table S for aluminum, silicon, and phosphorus. So we're going to look for table S and find those elements. Aluminum has an electronegativity of 1.6. Silicon has an electronegativity of 1.9, and phosphorus has an electronegativity value of 2.2. I found all of that information on table S, and so we are going to set number increases electronegativity increases across a period as well, and they didn't ask for it, but that's because of increasing nuclear charge. The protons, a number of protons is increasing, and that means that we can pull the valence electrons in tighter and hold on to them tighter. Number 53, compare the number of atoms per cubic centimeter in red phosphorus with the number of atoms per cubic centimeter in white phosphorus. They gave us the densities for these, and when we reread the reading, the red phosphorus was more dense. That means that the red phosphorus has more atoms per cubic centimeter. Being more dense means that your atoms are closer together. And it says the next question, 54, identify one element from the diagram that will combine with phosphorus in the same ratio of atoms as aluminum phosphide. So the same formula or the same ratio we would have to have something with the same oxidation state, and that would be members of the same group. So the other members of the same group for aluminum, it would be gallium or indium. The two possible choices for this question are gallium and indium, because elements in the same group will have the same ratios in formulas. For 55 to 57, these questions are all going to be based on the fact that the compounds KNO3 and NaNO3 are soluble in water. And number 55, they want you to compare the entropy of solid KNO3 with the entropy of dissolved KNO3. Solid has less entropy. Remember, entropy is randomness. The solid is more organized, so the solid has less entropy. The solution has more randomness, so the solution has more entropy. Number 56, explain why the total thermal energy of a sample containing 22 grams of NaNO3, sodium nitrate, dissolved in 200 grams of water at 20 degrees Celsius is greater than the total thermal energy of a sample containing 11.1 grams of sodium nitrate dissolved in 100 grams of water at 20 degrees Celsius. And the reason why the total thermal energy is more for the one with more grams is because more matter means that it will contain more thermal energy. Both samples are at the same temperature, but one sample has more particles than the other, so the more particles means more thermal energy. Number 57, compare the boiling point of a sodium nitrate solution at standard pressure to the boiling point of water at standard pressure. Remember, if we look at the thermometer, normal boiling point of water is 100 degrees Celsius. Normal freezing point of water is 0 degrees Celsius. As you dissolve things in water, the boiling point will increase and the freezing point will decrease. So the boiling point of the solution will be higher than the boiling point of the pure water. Next it says, base your answers for 58 to 61 on the information below and on your knowledge of chemistry. And the reading says that ethene and hydrogen can react at a faster rate in the presence of the catalyst platinum. The equation below represents a reaction between ethene and hydrogen. Now remember that ethene has a double bond here. It's an alkene, has the general formula CnH2n. Oops, that's not what that says. It has the general formula of CnH2n, meaning that you double the number of carbons to get the number of hydrogens in the formula. This is also an addition reaction because in addition, I'm spelling this wrong, we start with something that has a double bond and we make a product. The double bond changes to a single bond, and whatever we are adding connects to each hydrogen, each carbon that originally had the double bond. The molar mass of the product is going to be found the way that we find the molar mass of anything. We are going to do C2H8 because that's when you add it up. I'm sorry. Going to do C2H6 because that's what you get when you add it up. So you're going to do the mass of C on the table times 2, which gives you about 24. You're going to do the mass of hydrogen on the table times 6, which gives you about 6. And so you're going to get 30 grams equals 1 mole for the molar mass of ethane, which is the product. Remember that reactants are before the arrow, products are after the arrow. State the number of electrons shared between the carbon atoms in one molecule of the reactant, ethene. Because this is a double bond, each bond represents 2 electrons, so the number of electrons shared total will be 4 electrons because of the double bond. 60. Explain in terms of activation energy why the catalyzed reaction occurs at a faster rate. Remember that adding a catalyst lowers the activation energy. And that means that the particles reacting need to achieve do not need to absorb as much energy or do not need to possess as much energy in order for the reaction to happen. It is a faster reaction because of lower activation energy when there is a catalyst. Explain why the reaction is classified as an addition reaction. It is an addition reaction because a double bond was changed to a single bond. And when the double bond is changed to a single bond, and we add something to the molecule, it is an addition reaction. Base your answers to 62 and 63 on the information below. That means we need to look at this information for 62 and 63. It says in a titration, 50 milliliters of 0.026 molar hydrochloric acid is neutralized by 38.5 milliliters of potassium hydroxide aqueous. The word titration and the word neutralized tell us that we need to use the formula MAVA equals MBVB. And if we're using this formula, MAVA equals MBVB, the acid is HCl, so the molarity of the acid is 0.026 molar. The volume of the acid is 50 milliliters. We have the volume of the base, but we don't have the molarity of the base. Now it says numerical setup, so all we have to do is write the math. We do not need to solve. 63 says complete the equation for the neutralization by writing the formula of the missing product. Remember that neutralization is a fancy double replacement reaction, so we're going to do our inners and our outers. K goes in front of Cl. We are going to look up the oxidation numbers. We are going to look up the oxidation numbers and crisscross and drop the signs. They are both 1s, so they are going to cancel out, and we will get KCl, and then the H goes with the OH, and that's where the H2O comes from. Looking at 64 and 65, we have these molecular structural diagrams here. They are structural formulas because they show the structure, but we do not have lone pairs of electrons showing. When we look at these two, it says that 64 and 65 will both be based on this, so I have them both on the screen here. And it says table sugar, which is sucrose, is a combination of 2 simple sugars, glucose and fructose. The formulas below represent these simple sugars. Identify the functional group that appears more than once in the fructose molecule. So the fructose molecule has all of these OH groups, and so the answer to number 64, you could say OH, you can say that it is the alcohol group, or you can also call it the hydroxyl group because that's the name of the OH group. Explain in terms of atoms and molecular structure why glucose and fructose are isomers of each other, and it's because they have the same molecular formulas but different structures. So what that means is that when you count up all of the C's, all of the H's, and all of the O's, their totals will be the same for C, H, and O, but they're connected differently, and that's the definition of an isomer. Okay, so 66 through 70 are based on this reading. Baking soda, which is sodium hydrogen carbonate, can be commercially produced during a series of chemical reactions called the Solvay process. In this process, ammonia, sodium chloride, and other chemicals are used to produce sodium hydrogen carbonate and ammonium chloride. To reduce production costs, ammonia is recovered from the ammonium chloride aqueous through a different series of reactions. This series of reactions can be summarized by the overall reaction represented by the unbalanced equation below. First thing it says for 66 is write the chemical name for baking soda, and we're going to find this information on table E, that we know that baking soda is NaHCO3. That's the formula. We need the name, so we know that Na is sodium, and on table E, HCO3 is called hydrogen carbonate. So when we put it together, the name is sodium hydrogen carbonate. For number 67, it says determine the percent composition by mass of carbon in baking soda, and they gave you the overall mass, which was 84 grams per mole. So we're going to say, okay, so the formula has Na times 1, H times 1, C times 1, and O times 3. All they want is the percent by mass of carbon. So we're going to put the mass of one carbon over the total mass of 84 and multiply by 100. And this comes out to be 14%. It says state the color of brome cresol green in a sample of ammonia. Now on table L, ammonia is a base, and on table M, it tells us that brome cresol green is blue in basic pH. Basic pH, remember, is high. Acidic pH is low. 7 is neutral. Above 7 is base. Below 7 is acidic. It says determine the mass for 69. Determine the mass of ammonium chloride that must be dissolved in 100 grams of water to produce a saturated solution at 70 degrees Celsius. This is reading table G, finding out where the ammonium chloride line crosses 70 degrees Celsius. And for this question, it comes out to 62 grams, but you also get credit for 61, and you would also get credit if you chose 63. For number 70, it says balance the equation for the overall reaction to recover ammonia using the smallest whole number coefficients, and that reaction is here on my page above number 66. So I'm just going to flip back there, and we want to look. We have one N on each side. We have 4 H's on one side and 5 on the other. We have 1 Cl on one side and 2 on the other. Calcium is balanced with 1 on each side. Oxygen is balanced with 1 on each side. And if I put a 2 in front of my ammonium chloride and a 2 in front of my ammonia, that balances out the entire reaction. You also could optionally put 1s in front of the other species. For 71 to 75, it says, explain in terms of, rubbing alcohol is a product available at most pharmacies and supermarkets. One rubbing alcohol solution contains 2-propanol and water. The boiling point of 2-propanol is 82.3 degrees Celsius at standard pressure. Explain in terms of electronegativity differences why a C to O bond is more polar than a C to H bond, and that is because a higher electronegativity difference makes a more polar bond. To get the electronegativity difference, you just find the individual electronegativities on table S and you subtract them. Identify a strong intermolecular force of attraction between an alcohol molecule and a water molecule in the solution. Remember that our intermolecular forces of attraction are London dispersion forces, hydrogen bonding, and dipole-dipole. Since alcohol is a polar molecule, it has dipole-dipole forces. And I can't spell, but that's one of the types of forces it can make between the molecules of alcohol and the water, because water is also polar. Alcohol also has an oxygen connected to a hydrogen, which means that alcohol and water can make hydrogen bonds with each other as well. For number 73, determine the vapor pressure of water at a temperature equal to the boiling point of 2-propanol. This is a table H question, and we want to look up where water crosses 82.3 degrees Celsius, and the answer to number 73 is 50 kilopascals, but you would get credit anywhere from 48 to 52. For number 74, explain in terms of charge distribution why a molecule of 2-propanol is a polar molecule. Remember, we use the acronym MSNAP from molecules symmetrical is nonpolar, asymmetrical is polar, so the charge distribution is asymmetrical. Draw a structural formula of 2-propanol. Prop means 3 carbons. Anol means alcohol, means we have to stick an OH on somewhere, and the 2 tells us to put it on the second carbon. Remember, the O always has to get connected, and then the H gets connected to the O. For 76 and 77, it says silver-plated utensils were popular before stainless steel became widely used to make eating utensils. Silver tarnishes when it comes in contact with hydrogen sulfide, which is found in the air and in some foods. However, stainless steel does not tarnish when it comes in contact with hydrogen sulfide. Draw an electron dot diagram for the compound that tarnishes silver. Sulfur has the same number of valence electrons as oxygen. So H2S will have the same structure or very similar structure as H2O with the S in the oxygen's place. In the ground state, an atom of which noble gas has the same electron configuration as the sulfide ion? That's going to be S-2. And sulfur as an atom has the electron configuration 2, 8, 6. So because gaining electrons is negative, S-2 has the electron configuration 288, and it is argon on the periodic table that has the electron configuration 288. For number 78 to 81, it says common household bleach is an aqueous solution containing hypochlorite ions. A closed container of bleach is an equilibrium system represented by the equation below. Compare the rate of the forward reaction to the rate of the reverse reaction for the system. Rates have to be equal, and then the reason we know that is because they gave us the keyword equilibrium. State the change in oxidation number when Cl2 changes to Cl minus. And this starts out as a 0. Minus is the same thing as -1, so the oxidation number goes from 0 to -1. Explain why the container must be closed to maintain equilibrium. It must be closed so that no matter can enter or leave, because remember, changing concentrations, changing amounts of gases and aqueous substances can shift equilibrium and would change the equilibrium and would shift it, and it would not stay at equilibrium. 81, state the effect of the concentration of the ClO minus ion when there is a decrease, the state effect on the concentration of the ClO minus when there is a decrease in the concentration of OH. This is going to be a Le Chatelier's principle question, so this is number 81. I'm going to explain it up here. So if we decrease the concentration of hydroxide, that is the concept of take towards, which means that decreasing the OH will shift to the left. Shifting to the left will reduce the amount of what we have on the right. So ClO minus concentration will decrease because we're shifting away from where that ion is present in the reaction. 82 to 85 are based on this information and our knowledge of chemistry. Iodine has many isotopes, but only iodine 127 is stable and is found in nature. One radioactive iodine isotope, iodine 108, decays by alpha particle emission. Iodine 131 is also radioactive and has many important medical uses. Determine the number of neutrons in a sample of I-127. Remember when they write this like this? The 127 is our mass number. So we need to look up on the periodic table what the atomic number is. Remember, we do mass number minus atomic number to get neutrons. 127 minus 53 is 74. Why I-127 and I-131 are different isotopes of iodine in terms of protons and neutrons. Remember, isotopes have the same number of protons, but they have different numbers of neutrons. That's for all isotopes. Complete the decay equation here for I-108. Remember, the arrow is like an equal sign, so the top numbers and the bottom numbers have to be set equal to each other on each side. 108 would have to be 104 plus 4. 53 would be 2 plus 51. We look up element 51 on the periodic table, and that would be SB, or antimony. And finally, 85, the time required for an 80-gram sample of I-131 to decay until 1.25 grams remains. We have to look up on table N what the time for one half-life is for I-131. So if we look up on table N and we find iodine 131, the time for one half-life is 8.021 days. So 8.021 days is one half-life period. We want 80 grams to go down to 1.25. After the first half-life, it goes to 40. After the second half-life, it goes to 20. After the third half-life, it goes down to 10 grams. After the fourth half-life, it goes down to 5 grams. After the fifth half-life, it goes down to 2.5 grams. And after the sixth half-life, it goes down to 1.25 grams. That means that 6 times the 8.021 days goes by, and that means that when we multiply 6 times 8.021, we get 48.126 days. So you could have said 48 days, 48.1 days, 48.13 days, 48.126 days. And that is the end of the review of this blue exam. Hopefully it was helpful. There are 2 other videos on this exam for 1 to 30 and for 31 to 50. You have the links for those. Please feel free to share these with anyone else who you think might need some help with Regents Review. Happy studying!